Welcome back to JCAG-LAB. In the previous episode, we expanded our network by introducing a Cisco Catalyst switch and connecting multiple endpoints into our local network. We built a simple network consisting of laptop 01, laptop 02, PC 01, and PC 02. In the previous lab, we introduced a limitation. Devices belonging to different IP networks could not communicate with each other through a layer 2 switch alone. Communication between different networks requires a layer 3 device, such as a router, which we will discuss in a future lab. Networks are designed based on business requirements, security policies, and operational needs. Different departments, users, and systems often require different levels of access and security controls. In this lab, we will begin transforming our simple network into an enterprise-style design by introducing a concept called Virtual Local Area Networks, also known as VLANs. Before we configure VLANs, we need to understand why network segmentation is important. Imagine a company where sales employees, standard users, and IT administrators are all connected to the same network. Every device would exist in the same broadcast domain. This means broadcast traffic from one device could reach every other device connected to that network. Segmentation allows a large network to be divided into smaller logical groups based on function, department, or security requirements. One method of segmentation is using VLANs. A virtual local area network, or VLAN, allows us to divide one physical switch into multiple logical segments. Instead of installing separate physical switches for every department, we can use the same switching hardware while keeping traffic separated. For this lab, we will simulate an enterprise environment with 3 groups: sales, users, and information technology. Before creating these separate groups, we will first perform a demonstration using a single flat network. For this demonstration, every device will temporarily belong to the same IP network or subnet. We will first observe how devices behave when they are placed into the same network. We will use the following temporary network: 192.168.100.0/24. After we observe how the devices in this flat network behaves, we will introduce VLANs and create logical separation between departments. Before we continue, we will need the topology from the previous lab, Lab 02. Now let's continue with the current lab. In the previous lab, our devices were assigned to different IP networks. For this demonstration, we will temporarily move all devices into the same IP network. Laptop 01 and Laptop 02 will be assigned the following addresses: Laptop 01 192.168.100.10, Laptop 02 192.168.100.20. Next, we will change the addresses assigned to PC 01 and PC 02. Previously, these devices belonged to a different IP network. We will move them into the same network as the laptops. Assign the following addresses: PC 01 192.168.100.30, PC 02 192.168.100.40. Now we will add one more device to the workspace. Rename the device Laptop 03. Assign the following IP address: 192.168.100.50. At this point, every device is connected to the same switch and belongs to the same IP network or subnet, but every switch interface is still assigned to the default VLAN, which is VLAN 1. Because all devices are currently in the same VLAN and the same IP network, we should expect communication between all endpoints. Let's test this. Open Laptop 01, select the Desktop tab, open the command prompt, first ping Laptop 02 192.168.100.10 100.20. Next, ping PC01 to 192.168.100.30. The ping should also be successful. Now ping PC02 192.168.100.40. Finally, ping laptop 03 192.168.100.50. Laptop 01 can communicate with every device connected to the switch. The reason is simple. All devices belong to the same Layer 2 broadcast domain. When laptop 01 needs to communicate with another device, it first needs to discover the destination MAC address. To do this, it sends an Address Resolution Protocol request, also known as ARP. The ARP request is a broadcast message. Because all devices are in the same broadcast domain, every device receives this broadcast. The correct device responds with its MAC address. Laptop 01 can then create an Ethernet frame and send traffic directly to the destination device. Communication works because every device is part of the same IP network and broadcast domain. Now that we have confirmed communication works in a flat network, let's discuss why this design is not ideal for an enterprise environment. Enterprise networks require segmentation for several reasons: security, better performance, simplified management, and controlling communication between different groups. One possible solution would be to install a separate physical switch for each department. A virtual local area network, or VLAN, allows us to divide one physical switch into multiple logical segments. Instead of using separate physical switches for every department, we can use the same switching hardware while keeping traffic separated. For this lab, we will create 3 VLANs: VLAN 10 and name it Sales, VLAN 20 as users, VLAN 30 as IT. Each department will have its own logical network segment. Now let's begin creating our VLANs on the switch. Open switch 01. Select the CLI tab. First, enter privileged exec mode. Type enable. Next, enter global configuration mode. Type configure terminal. Now we will create our first VLAN. Type VLAN 10. This will create VLAN 10 and enters VLAN configuration mode. Assign the name. Name sales, then type exit. The VLAN is created and returns us to global configuration mode. Now create VLAN 20. Type VLAN 20. Assign the name, name users, then type exit. Finally, create VLAN 30. Type VLAN 30. Assign the name, name IT, then type exit. Now let's verify that our VLANs were created successfully. Type do show VLAN brief. This command displays all existing VLANs, their status, and the switch interfaces assigned to each VLAN. Notice that the default VLAN is VLAN 1. By default, all switch interfaces initially belong to VLAN 1. Creating a VLAN does not automatically assign devices to it. We still need to configure each switch interface manually. Now we will assign each device to the appropriate VLAN based on its role. Laptop 01 and Laptop 02 belong to the sales department. They will be assigned to VLAN 10. If you remember from the previous lab, Laptop 01 is connected to switch 01's Fast Ethernet 0/1 interface. Laptop 02 is connected to Fast Ethernet 0/2. Let's configure the first interface. Type interface Fast Ethernet 0/1. Now configure the interface as an access port. Type switch port mode access. Next, assign this interface to VLAN 10. Type switch port access VLAN 10. Then type exit. Now configure Laptop 02. Type interface Fast Ethernet 0/2 or in TF 0/2 as shortcut command. Configure the interface as an access port. Type switch port mode access. Assign the interface to VLAN 10. Type switch port access VLAN 10, then type exit. Both sales devices are now members of VLAN 10. Next, we will assign PC01 and PC02 to VLAN 20. PC01 is connected to Fast Ethernet 0/3. Enter NTF 0/3. Configure the interface as an access port. Type switch port mode access. Assign the interface to VLAN 20. Type switch port access VLAN 20, then type exit. Now configure PC02, enter NTF 0/4, configure the interface as an access port, type switch port mode access, assign the interface to VLAN 20, type switch port access VLAN 20, then type exit. Both user workstations are now assigned to the user's VLAN. Finally, we will configure Laptop 03. Laptop 03 represents the IT administrator workstation. It will be assigned to VLAN 30. Laptop 03 is connected to Fast Ethernet 0/5. Enter NTF 0/5. Configure the interface as an access port. Type switch port mode access. Assign the interface to VLAN 30. Type switch port access VLAN 30, then type exit. Laptop 03 is now assigned to the IT VLAN. At this point, all devices are still physically connected to the same switch. However, the switch has logically separated their traffic into different broadcast domains. We can verify this by checking the VLAN assignments on the switch. Type do show VLAN brief. The output shows that Fast Ethernet 0/1 and Fast Ethernet 0/2 belong to VLAN 10 sales. Fast Ethernet 0/3 and Fast Ethernet 0/4 belong to VLAN 20 users. Fast Ethernet 0/5 belongs to VLAN 30 information technology. All remaining interfaces are still assigned to VLAN 1 by default. Now let's test the results. Open Laptop 01, select the Desktop tab, open Command Prompt. First, ping Laptop 02, 192.168.100.20. The ping should succeed. Why? Because Laptop 01 and Laptop 02 are both members of VLAN 10 sales. They are part of the same Layer 2 broadcast domain. Now let's test communication with PC01. Ping 192.168.100.30. The ping should fail. Next, ping Laptop 03, 192.168.100.50. This ping should also fail. Although all devices are connected to the same physical switch and still use the same IP network, VLANs have separated them into different Layer 2 broadcast domains. This result may seem confusing, especially when compared to the IP network segmentation demonstration from the previous lab. In the previous lab, the laptops and PCs belong to different IP networks connected to the same physical switch. In this lab, the situation is different. All devices still have addresses from the same IP network or subnet, and they are still connected to the same physical switch. So why can they no longer communicate? The answer is VLAN segmentation. VLANs operate at Layer 2. Each VLAN creates its own separate broadcast domain. When Laptop 01 tries to communicate with PC01, it first needs to discover PC01's MAC address. To do this, Laptop 01 sends an Address Resolution Protocol broadcast, also known as ARP. However, that broadcast is limited to VLAN 10. It cannot cross into VLAN 20. Because PC01 never receives the ARP request, it never responds with its MAC address. The same process occurs when Laptop 01 tries to communicate with Laptop 03 in VLAN 30. The traffic is separated because these devices belong to different broadcast domains. This demonstrates an important networking concept. VLANs provide Layer 2 separation. even when devices are connected to the same physical switch. Now let's move from our demonstration design to a more realistic enterprise design. In a real network environment, each VLAN is normally assigned its own dedicated IP subnet. Our final design will be VLAN 10 sales 192.168.10.0/24, VLAN 20 users 192.168.2.0.0/24, VLAN 30 information technology 192.168.30.0/24. So let's reconfigure the IP addresses of the endpoint devices or hosts to fit our final design. This design makes the network easier to understand, troubleshoot, and manage. It also prepares the network for Layer 3 inter-VLAN routing, which will be introduced in the next lab. Before we finish, we need to save the switch configuration. Type N. This returns you to privileged exec mode. Now type write memory. This saves the running configuration, so the switch configuration will remain available after a restart. Finally, save the packet tracer project. Select File from the menu bar. Choose Save As. Save the project as lab-03. In this lab, we learned how VLANs allow network engineers to create logical network separation using the same physical switching infrastructure. We learned how VLANs separate broadcast domains. We learned how devices can be grouped based on their role or department. And we learned why enterprise networks normally assign separate IP subnets to different VLANs. We also learned that VLANs and subnets work together, but they are different concepts. A VLAN provides Layer 2 segmentation. A subnet provides Layer 3 addressing. However, we now have a new challenge. Our sales, users, and information technology VLANs are separated and cannot communicate with each other. In the next episode, we will solve this problem by introducing a router and inter-VLAN routing. We will learn how Layer 3 devices allow communication between different VLANs while maintaining proper network segmentation. Thank you for watching. I'll see you in the next lab.